Example 1. The Brayton cycle. The question states that a simple ideal Brayton cycle uses helium as the working fluid, operating with 83 kPa and 15 degrees Celsius at the compressor inlet, has a pressure ratio of 14 and a maximum cycle temperature of 700 degrees Celsius. How much power will the cycle produce when the rate which the helium is circulated about the cycle is 50 kg per minute? Alright, so from the question, it states that it is a simple Brayton cycle. Although normally in Brayton cycle, we are going to use the atmospheric air as our substance. However, in this question, it's already given to us the substance used is helium. Therefore, we are going to use all the data for the helium. So now if we draw the simple ideal Brayton cycle on the TS diagram, it will look like this. And again, the sequence of the state number is not very important. It can be anywhere. So let's start the cycle, state 1 over here, which is before entering our compressor, and state 2 will be leaving our compressor and before entering our combustion chamber, and state 3 will be after leaving the combustion chamber and before entering our turbine, and state 4 is after leaving our turbine and before entering the constant pressure heat rejection process. And as we know, the process 4 to 1, there will be no device involved in this process. However, we are going to assume it as constant pressure heat rejection process. Now from the TS diagram, we know that process 1 to 2 will involve the work input consumed by the compressor. Process 2 to 3 will involve with constant pressure heat addition to our system. Process 3 to 4 will produce the work, so we are going to have work out throughout this process, and the process 4 to 1 is the constant pressure heat rejection. Therefore, we're going to have the terms Q out. Now let's have a look at the informations given to us from the question. So from the question, given to us is the information for the compressor inlet, 83 kPa and 15 degrees Celsius. Therefore, we have the pressure at state 1 will be 83 kPa and the temperature at state 1 will be 15 degrees Celsius. We may want to convert 15 degrees Celsius into Kelvin, and we're going to get the value of 288 Kelvin. Next will be the pressure ratio. RP is equal to 14, so we know that RP is equal to P2 over P1 and is equal to P3 over P4. Also given to us is the maximum cycle temperature of 700 degrees Celsius, and this value is actually representing the temperature at state 3, 700 degrees Celsius, and we convert into Kelvin, we're going to get 973 Kelvin. And the last information that is being given is the mass flow rate of the helium, which is 50 kg per minute. And if we convert the mass flow rate to the unit of kilogram per second, we are going to get the value of 0.8333 kilogram per second. This question requires us to find the power that the cycle will produce. This is actually referring to the W dot net out, and it is given by power out minus power in. Since all the devices used in the simple Brayton cycle is steady flow devices, therefore we are going to use the steady flow energy equation in our analysis. Thus we can get the power net out will be equal to m dot h3 minus h4 for the power out minus m dot h2 minus h1 for the power in. Since the working fluid used is helium, which is type of gas, therefore the power net out will now become m dot Cp T3 minus T4 minus m dot Cp T2 minus T1. Therefore, in order for us to find the power net out for this simple ideal Brayton cycle, first we need to find the temperature for state 1, state 2, state 3 and state 4. For state 1, we already have the values for the temperature 15 degrees Celsius or equal to 288 Kelvin as given from the question. In order for us to find the temperature at state 2, we are going to use the isentropic relation between the temperature and pressure. We already know the values for the temperature at state 1, and P2 over P1 is actually the pressure ratio, and it is equal to 14. For the specific heat ratio K, we are going to refer to table A2. For the types of gas is helium, and the value for the K will be 1.667. Once we substitute all the required values and we calculate, we are going to get the value for the temperature at state 2 will be equal to 827.91 Kelvin. For the temperature at state 3 given from the question is 700 degrees Celsius, and when we convert into unit Kelvin, we are going to get the value of 973 Kelvin. In order for us to find the temperature at state 4, we are going to use the isentropic relation of temperature and pressure. Note that P3 over P4 is the pressure ratio, which is equal to 14. Once we substitute the required values and calculate, we are going to get the values of T4 is equal to 338.47 Kelvin. Now we can solve the power net out for the simple Brayton cycle. After we substitute and calculate, we are going to get the value of 409.42 kilojoule per second, and we know that kilojoule per second is equal to kilowatt. You may also want to try to find the value for the power net out by using the equation of heat transfer rate in minus heat transfer rate out. Since for a cycle, power net out will be equal to heat transfer rate net in.